Hi, in this video we're going to talk about structural isomers. Isomers, let's write isomers here. Isomers, same formula. Different arrangement of atoms in space. Different arrangement. Oop, let's see. All right, different arrangement of atoms in space. Okay. All right, so let's see if I got my, no, my pen is acting up, but I guess we'll just have to deal with it being, this, this bright and this thick. Okay, so anyway, this particular problem reads, write the skeletal line structure for all of the structural isomers of C6H14, provide the IUPAC name for each structural isomer. Can two structural isomers have the same IUPAC name? All right, well, we're talking about C6H14. Let me erase my little doodles here. As I said, my pen is acting up, so I don't really know why, but we'll just do our best. Oh, there we go. Now it's acting normally again. All right, so C6H14, if we break this down, we see that this is CnH2n plus 2. This then has to be an alkane because that's the formula unit format for any alkanes. We can prove this to ourselves. We could write out C6 in a straight line. We can fill in H's at all the spots here. So each carbon has 4 bonds. And we can count off then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens, proving to ourselves that this needs to be an alkane. Now, this would be the simplest of the isomers because this is C6H14. We have 6 carbons in a row, straight line. That would be hex for 6, all single bonds, ane. And this version, this isomer of C6H14 would be known as hexane. Okay, let's take a look at others. Now, if we're going to deviate from this hexane, we need to chop off one of the carbons and go to 5 carbons in a row. And let's put, I'm going to stop using the hydrogens in a second. Let's put one of the carbons off this second carbon from the left. And this will be the last one we draw all the H's for because we just want to verify that we have the right number of H's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have all 14 there as well. So this is still C6H14, but it looks a little bit different here because we don't have 6 carbons in a row. We have 5 carbons in a row, and off one of them we have a single methyl group. So our straight chain of 5, and I'll put this in blue here, our straight chain of 5, okay, 5 gives us pent, they're all single bonds, ane, pentane, and now we have to figure this out here. What number is this particular carbon, this methyl group, off of? Well, if we go from the right, 1, 2, 3, 4, it's going to be carbon number 4. If we go from the left, 1, 2, it's going to be number 2. We want the lowest number, so this methyl group is going to be off of 2. So we write this 2 with a dash, and then this methyl group here, let's write it in yellow, some form of yellow. This methyl group is on the 2, So 2-methylpentane is the name of this particular isomer of C6H14. All right, well, let's take that methyl group and move it somewhere else. Let me get my green pen back. Let's do another pentane. Let's put it off the middle. Oh, I said I was going to stop doing H's, but old habits die hard, I guess. You can count the H's here. There will be 14. We don't need to do that. So we have 1, 2, 3, 4, 5. We still have 5 carbons. Pentane, single bonds. But now, where's this methyl group? It was on the second one before. Well, 1, 2, 3. It's on the third one from the left. From the right, 1, 2, 3. It's on the third one from the right. So it really doesn't matter which way we number these. Three-methylpentane. Okay, well, from here, students might be tempted to then move this methyl group to here. Okay. However, if you take a mirror image and you put it here, it's no different than this up here. Okay. So for the pentanes, there are no other opportunities to deviate. So we need to go to now butane. What can we produce if we have just 4 carbons in a row? Having 4 carbons, we're going to need to put 2 methyl groups on there to give us our total of 6. Let's try putting them both on this second one. If we put them both on the end, we end up with pentane with it coming off the second. So that's not going to help us at all. We can't put it on either of the ends because we're going to get things we've already had before. I'm going to leave the hydrogens out this time. All right, so looking at this, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. All right, so 4 is the longest chain. I'll put this in pink. That appears pretty well here. So here is our chain, okay? And we can number these 1, 2, 3, 4 or 1, 2, 3, 4. Well, left from the left, that gives us a lower number for these substituents here. So this is a single bonds, butane, and off this 2 we have not 1 but 2 methyl groups. We have a methyl group up here, and we have a methyl group down here. So we have 2 methyl groups, one up top, one at the bottom. They're both on 2. All right. So one's on 2. The other is going to be on 2. Okay. And we have 2 of them. Well, how are we going to write that if we have 2 of them? 2, 2. They're both methyl. Di is for 2. And methyl. 2, 2 dimethylbutane. Straight chain are kind of foundation chain is 4 carbons. That's but. They're all single bonds. Ane. We have a methyl and a methyl both off of 2. So this would be a methyl off this 2 and a methyl off this 2. So 2, 2 dimethylbutane. So that's another isomer. Well, we can take this and we can take this arrangement and we can try putting them on the third, but as you can see, if we flip this over, it ends up being the same molecule. So putting both on 3 is not going to help. So let's look at one more option. Let's get our butane backbone. That's what I was looking for before, not foundation, our backbone. And let's put one off of 2 and one off of 3 when counting from left to right. 1, 2, 3, 4. Okay. Well, let's see. 1, 2, 3. There's a chain of 3. 1, 2, 3, 4. There's a chain of 4. 1, 2, 3, 4. There's a chain of 4. All right. So this is different from everything else we've drawn. This is still butane. but we have a methyl off of 2 and a methyl off of 3. Let me try color coding some of these. And let's try yellow. Okay, well, the one off the 2, then we have the one off of the 3, and we still have 2 methyl groups, so this is still going to be dimethyl. But as I said, one is off the 2, one's off the 3. And this is our last permutation, because if we go to 3, we're going to have 3 to put off, and just take my word for it, we're not going to make any arrangement we haven't already seen, because when we're putting them off the ends, we're still going to get longer chains, and it's going to be either a butane or a pentane. All right, so these are our isomers for C6H14. We have hexane, 2-methylpentane, 3-methylpentane, 2,2-dimethylbutane, and 2,3-dimethylbutane. Now, the final question of this was, can 2 structural isomers have the same IUPAC name? And the answer is no. If they have the same name, they're not isomers, they're the same exact molecule. Okay, now to finish up this problem, we need to get the skeletal structure of each, and I don't have the structures up there, but we're going to talk about them. So our straight chain of hexane, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So there's our skeletal structure. Our 2-methylpentane, so we need 5, 1, 2, 3, 4, 5, and off the 2. All right, so that's our 2-methylpentane. Our third structure, pentane, but with the methyl off the center one. Okay, then we had the 2,2-dimethylbutane, 1, 2, 3, 4, one up and one down, and I think that was it. Oh wait, no, we had our 2,3-dimethylpentane. So in addition to the IUPAC naming not being the same for 2 structural isomers, here are our skeletal structures.